Volcanoes are powerful reminders of Earth's immense energy. They are windows into the fiery depths of our planet where molten rock known as magma churns and boils. When this magma rises to the surface, it erupts, creating a spectacle both awe-inspiring and terrifying. Volcanic eruptions, though often destructive, are natural processes that have shaped Earth's landscapes for billions of years. From the Hawaiian Islands to the towering peaks of the Andes, volcanoes have left their mark on every continent. They have played a crucial role in the evolution of Earth's atmosphere and oceans, and even the emergence of life itself. Eruptions can unleash deadly phenomena, from scorching pyroclastic flows to devastating mudslides. In this exploration of Earth's fiery fury, we delve into the science behind volcanic eruptions, examining their causes, characteristics, and consequences. Deep beneath Earth's surface lies a realm of intense heat and pressure. Here, within the planet's mantle, rocks melt to form magma, a molten mixture of minerals, gases, and dissolved volatiles. Magma is less dense than the surrounding solid rock, causing it to rise buoyantly towards the surface. As magma ascends, it may accumulate in underground chambers called magma chambers. When the pressure exceeds the strength of the surrounding rocks, the magma forces its way upward through cracks and fissures, ultimately erupting onto the surface. The type of eruption and the shape of the volcano that forms depend on several factors, including the composition of the magma and the amount of dissolved gases it contains. Over time, these eruptions can create mountains that rise thousands of meters above the surrounding landscape. Volcanoes are not all created equal. They exhibit a wide range of shapes, sizes, and eruption styles, reflecting the diversity of geological processes that create them. Shield volcanoes, named for their broad, gently sloping profiles, are formed by effusive eruptions of fluid, basaltic lava. These eruptions typically produce relatively calm lava flows that can travel great distances, creating vast volcanic plateaus over time. The Hawaiian Islands are a prime example of shield volcanoes built up over millions of years by countless eruptions. Stratovolcanoes, also known as composite volcanoes, are characterized by their steep, conical shapes and their explosive eruptions. Cinder cone volcanoes are smaller and have a distinctive cone shape with a large crater at the summit. They are formed by the accumulation of pyroclastic materials such as ash, cinders, and volcanic bombs ejected during explosive eruptions. Volcanic eruptions span a spectrum of eruptive styles, from gentle lava flows to catastrophic blasts. Effusive eruptions are characterized by the relatively calm outpouring of lava onto the Earth's surface. These eruptions typically involve basaltic magmas, which are relatively low in silica and have low viscosity. The fluid nature of basaltic lava allows gases to escape easily, resulting in less explosive activity. Explosive eruptions, on the other hand, are characterized by the violent ejection of magma, ash, and gases into the atmosphere. These eruptions are often associated with more viscous andesitic to rhyolitic magmas, which tend to trap gases, leading to pressure buildup. When the pressure exceeds the strength of the surrounding rocks, a violent explosion occurs, fragmenting the magma and propelling it skyward. Plinian eruptions are among the most powerful and destructive types of explosive eruptions. Volcanic eruptions pose a multitude of hazards to human life and infrastructure. Understanding these hazards is crucial for mitigating risks and ensuring the safety of communities living in volcanic regions. Lava flows, while visually dramatic, generally pose a relatively low risk to human life as they move slowly enough for people to evacuate. However, lava flows can cause significant damage to property and infrastructure, engulfing homes, roads, and agricultural land. Pyroclastic flows are among the most dangerous volcanic hazards, consisting of dense, fast-moving avalanches of hot gas, ash, and volcanic debris. These flows can reach speeds of hundreds of kilometers per hour, incinerating everything in their path. Ashfall is a common hazard associated with volcanic eruptions, particularly explosive ones. Volcanic ash consists of fine particles of rock and glass that can blanket the landscape, causing respiratory problems, damaging crops, and contaminating water supplies. Ashfall can also disrupt transportation, leading to road closures and flight cancellations. Predicting volcanic eruptions is crucial for saving lives and mitigating damage. Volcanologists use various tools to monitor volcanoes and issue timely warnings. Seismic monitoring is a primary method to track volcanic activity. Earthquakes often precede eruptions, indicating magma movement. Seismometers help detect and locate earthquakes, revealing magma movement. Volcanic eruptions, particularly large, explosive ones, can have significant impacts on Earth's climate, both in the short term and over longer timescales. Volcanic eruptions inject massive amounts of ash, gases, and aerosols into the atmosphere, where they can linger for months or even years. These particles can reflect sunlight back into space, reducing the amount of solar radiation reaching Earth's surface and leading to a cooling effect. Sulfur dioxide, a major volcanic gas, is particularly effective at reflecting sunlight. When sulfur dioxide reaches the stratosphere, it can react with water vapor to form sulfate aerosols. These aerosols can remain in the stratosphere for several years, reflecting sunlight and causing global cooling. The eruption of Mount Pinatubo in the Philippines in 1991 is a prime example of the cooling effect of volcanic eruptions. Throughout history, volcanic eruptions have shaped landscapes, influenced cultures, and caused widespread devastation. The eruption of Mount Vesuvius in 79 AD buried Pompeii and Herculaneum, preserving them in a remarkable time capsule. The 1815 eruption of Mount Tambora in Indonesia was the largest in recorded history, causing a global volcanic winter. The 1980 eruption of Mount St. Helens in Washington state was the deadliest and most economically destructive in US history. Living near a volcano while presenting inherent risks is a reality for millions of people worldwide. By understanding volcanic hazards and taking appropriate precautions, communities can coexist with these powerful forces of nature and minimize the risks to life and property. One of the most crucial aspects of living safely in volcanic regions is having a well-defined evacuation plan. Authorities and emergency management agencies should develop comprehensive evacuation plans that clearly outline evacuation routes, assembly points, and procedures for different scenarios. Residents living in volcanic areas should be familiar with the different volcanic hazards and their potential impacts. Preparedness kits are essential for families living in volcanic regions, including supplies such as water, non-perishable food, first aid supplies, a battery-powered radio, flashlights, extra batteries, and copies of important documents. Volcanic activity is not randomly distributed across Earth's surface, but is concentrated along specific zones that coincide with plate boundaries, the dynamic edges of Earth's tectonic plates. Understanding plate tectonics, the theory that explains the movement of Earth's lithosphere, is crucial for understanding the distribution and behavior of volcanoes. Most volcanoes occur along convergent plate boundaries where two tectonic plates collide. When an oceanic plate collides with a continental plate, the denser oceanic plate is forced beneath the continental plate in a process called subduction. As the oceanic plate descends into the mantle, it heats up, releasing fluids that lower the melting point of the surrounding rocks, generating magma. This magma can then rise to the surface, forming volcanoes. Volcanoes can also form along divergent plate boundaries where tectonic plates move apart. As plates diverge, magma from the mantle rises to fill the gap, creating new crust. Volcanoes, while awe-inspiring and scientifically fascinating, are a powerful reminder of the immense forces that shape our planet. Their eruptions, though often destructive, are natural processes that have played a crucial role in Earth's evolution. By understanding the science behind volcanic eruptions, monitoring their activity, and taking appropriate precautions, we can coexist with these powerful forces of nature and minimize the risks they pose to human life. As we continue to study volcanoes and develop new technologies for monitoring and predicting their behavior, we gain a deeper appreciation for the complex interplay of geological processes that shape our world. By respecting the power of volcanoes and heeding the warnings they provide, we can strive to live in harmony with these magnificent and sometimes merciless forces of nature. Thank you for joining us on this journey through the world of volcanoes.